In this video, we are going to be solving problem 24 in chapter 2 of the AP Physics textbook, page 51. So it says, figure P2.24 represents part of the performance data of a car owned by a proud physics students. A, calculate from the graph the total distance traveled. B, what distance does a car travel between the times t equals 10 seconds and t equals 40 seconds? C, draw a graph of its acceleration. D, write an equation for x as a function of time for each phase of the motion. And that's kind of confusingly phrased, represented by 0A, AB, and BC. All that means is that's how they want you to label that part of the problem. And then E, what is the average velocity of the car between t equals 0 and t equals 50? So the first part of the problem is pretty easy, and I actually have an enlarged version of the picture. Here we go. So remember, the first part of the problem asks us to find the total distance traveled, and to do that, we know that it's just the area under the VT curve. So we just have to find this area here, and we can divide that up into segments. So the first segment is that right here. Apparently I can't draw a straight line. This rectangle is our second segment, and then this triangle is our third segment. So remember, the area for a triangle is 1/2 base times height. So this is problem number 24, part A. So 1/2 base times height. The base is that 15 seconds. And then the height is 50. So calculate that, you should get 375. Okay, then for this rectangle, we're going to do length times width. So length times width, well, the length, I'm just going to say that's the height, is 50. And then the width is going to be 40 minus 15, which is 25. So you should get 1,250 there. Okay, then for this last segment, we have another triangle. So again, we're going to do 1/2 base times height. So this time our base is just 10 seconds. Again, our height is 50. So there we get 250. And then we just add these all up. And you get 1,875 meters. Okay. Now for part B, B asks, let me just look it up real quick. B asks, what distance does the car travel between the times t equals 10 and t equals 40? So we kind of want to divide this up again. So we're looking for between here and here. So if you look, you can divide this up. So we have sorry, I just realized you couldn't see that. Anyway, we're going from 10 to 15, and we get a rectangle here. And then up here, we have a triangle, and then we've got that whole rectangle there. So we want to do the area of this small rectangle plus this triangle plus this rectangle. So if you look closely, you can actually see that it intersects more at 33. So the height of our first rectangle is going to be 33. And then the width is 5. Then for this small rectangle, the base is going to be 5. And then the height is going to be 50 minus 33, which is 17. And then this rectangle here will have a height of 50. And then the width of 25. So if you do all the math out, you should end up with 1,457.5 meters. Okay, now we're going to do part C. Part C asks us to draw a graph of its acceleration versus time for the whole interval, 0 to 50 seconds. So the way I'm going to do this is I'm going to find the slope at each, so you know the tangent line, and that'll get me the acceleration. So for this first segment, we know that one point happens at 15, 50, so that would be that point right here. And then another happens at 0, 0. So we can just find the slope of that line. So 50 minus 0 over 15 minus 0, and you end up with 3.3 meters per second squared. Now the next interval is pretty easy. It just has a slope of 0. And then the next interval, so we've got one point at 50, 0. And then we've got another point at 40, 50. So, to get the slope, it would just do and you end up with -5 meters per second squared. So if we graph the acceleration, and I will do that right here. So between 0 and 15 seconds, the object has an acceleration of 3.3. So That's about 3.3. So it's going to look like that. Then, from between 15 and 40 seconds, it has an acceleration of 0. Then, between 40 and 50 seconds, it has an acceleration of -5. So, there's your acceleration graph. And I'm going to do the next part of the problem in another video.